All right, if it stops because I have another physics class next, tomorrow. So I'll finish recording. Alrighty, so, I was worried that how many students were gonna be able to come back or not be able to come in today. For those of us who are new to collegiate, even if your ISD is closed, you still have to come in, okay? So I'm tossing that out there, just in case.
You follow this calendar, not your school.
We follow our calendar. So, just in case if you were wondering. So homework number 1, get that out. Get your notes out as well because we're going to do notes today. And if we get to, we're going to color code our DT-BT graphs. And that's the reason for the colors on your tables. If not, then we'll get to that on Friday. Also here on our formula chart, I'm going to start highlighting the equations every time we start to get to them because that might be useful rather than waiting till the last second or waiting until the day of the quiz or test to look at the formula chart and not have a clue where the equations really are, right? Everyone's ready? Everything's put up? Ready to learn. So, thank you, Bailey, for telling me that question number 4 was acceleration. I did not mean to do that at all. I knew we were not going to be able to get to those equations. I just thought I had removed them all. So, today, though, we should get to acceleration and be perfectly good on homework number 2, though. Looking at homework number 1, you needed to use their ruler first. You needed to cut it off, whatever you needed to do, whether you just cut it nice and pretty,
Or just bend your paper.
or bend your paper, whichever way.
Really badly. I don't even know if I can do this part right.
So here we go. Question A at the top. It asks you, what is the distance? Here's what I tell my students as we continue throughout the school year. When you see the word distance, you hopefully start thinking of add, okay? When you see the word distance, I need you to think of add. When you see the word displacement, I need you to think of a straight line, okay? From the end to the beginning, from the beginning to the end, a straight line. So distance means to add all of the distances together. Displacement means a straight line from the beginning to the end without no curves or turns. It says here that the distance from the start to the A is going to be what? I got 3.3. As we continue throughout the school year.
What?
I got 2.8.
What are you? What? What's
Sorry.
not buy me again?
Did I do that in the dark?
I got two.
All
I
right.
got 2.8. I'm sorry. I'm like,
I got,
3.5 on my own package.
all right, I got 2.7. I apologize, sorry.
wait, is it okay if we're like one off? Because I got 2.8.
So here's what I do, and I'm glad she brought that up. When we do our test or quiz, we will have where we're going to need rulers at the time. And when that comes into play, I have no problem giving you credit for 2.8. I have no problem giving you credit for 2.6. But I do have a problem with giving you credit at 2. I have a problem giving you credit at 3.
Okay, I got
Okay,
2.8.
so-
I chose after it, like before it.
You're more than welcome to go from 1/10 over, above, or below. But what I want us to all know is that when you do measure something, you measure from the middle to the middle. Okay?
Oh, so
And
like,
the reason why we measure from the middle to the middle is there's an equation later on with Newton's law of gravitational motion, and because of that, he measures from the middle of one object to the middle of the other object, not from the end to the end, but in physics, it's measured from the middle of this object to, let me say it this way, it's measured from the middle of the mass of that object to the middle of the mass of the other object. And so that's how we measure in physics. Okay, so that might be a reason why your numbers may be a little bit off. But in physics, that's how we do take our measurements. But the displacement's absolutely the same of 2.7 as well. Now the total distance here though, from the start to point B, meaning that you have to get this line and this line, add them together. What I did was I got 2.7 here, I got 1.8 over here, and then on this line over here, I got 3.7. I went ahead and just measured all the lines, just to knock it out of the way.
Yeah.
So I thought it was much easier. Distance, I needed to add again, 2.7 plus 1.8, I got 4.5. The displacement from here is not going to be 4.5 again. We had to use our ruler, get a straight line from the start to the end, which was the middle of dot B.
Okay, I got 4 points.
And I got 4.4 actually.
I keep getting 1 point over, like
Over-
everything.
At least you're consistently wrong. I'm kidding.
Thank you. That's so nice.
I got 4.4. So, you know what I think what you're doing is I think you're measuring from the beginning of this object to the end of that
Yeah.
object. If that makes sense. But now we know, and I think this is a good homework for us to do, is that now we know in physics class, she prefers from the middle of the object to the middle of the object. We have an equation that correlates with that later on.
I couldn't have just been consistently wrong when I knew what I was supposed to do. I had to be consistently wrong and wrong.
And wrong.
Nice.
That's all right. It's not a problem.
Yeah, that's such a confidence booster, Miss Munson.
So it says here, the distance, again, we have to think about adding, from the beginning, which is 2.7, plus the leg of A to B, which is 1.8, plus from B to C, which was 3.7. Hopefully you got something of 8.2. I thought this was a lot easier, adding those three numbers rather than using the ruler. And if not, let me double check. From here, I got 3.7.
Since I do have like a couple, I'm like 1 point off, wouldn't that mean I'd be like a couple point off?
So if you got 8.3 or 8.1, I'm perfectly
I
good
got
with that.
8.4.
Can we stop for a moment and look at this? Here's where I think some of us may be a little bit off. This ruler right here, the actual 0 starts here at this line right here, not at that line over there, if that makes sense.
I just realized
That
like-
explains a lot as to why
If-
my.
Yeah.
And so I think this is a good homework because I'm telling you, I'm gonna knock those points off later on. We've got to do practice first. So if that makes sense, that I like for us to practice and it's not gonna count against you, so that way you'll know. Look at this ruler. This ruler right here doesn't start at 0 until over here. Some of the rulers start at the end.
No,
This
but
ruler starts over here.
That's clear.
This paper, there goes the 0. Okay?
So if you
So-
count from there till to get to the middle, and you can like see how much it is, like you count from that line and to get to the middle to get to 5. Like,
Count it from like the beginning.
What,
of
from here to
that
here?
like from the millimeter, and you try and get to 5, like where it's the middle, you could like see where each dot is, like in between the lines.
Oh, the little tiny baby ones?
Yeah.
And those are kind of tough. She's saying they're right here. They're way up here at the top, and they're there. They're just kind of rough to see. You definitely need a power light to see them. Couldn't do that one in the dark.
So would you accept
So-
4?
And on quiz and tests, no, I won't. On labs, no, I won't. So that's the reason why we're doing homework now, so that way we know. It doesn't count against you. You're just learning right now in the process. The displacement, though, because if that was the case when somebody was coming as a contractor to work on your house, those 1 millimeters here and there are going to make a huge difference later on. My contractor better be the best carpenter ever.
Yeah,
Okay,
you'll check all of
Jesus.
his work with this.
All right, let's go. Displacement, though, from start to the letter C was a straight line, so you might have wanted to come over here, draw you a straight line. Again, though, we do it from the middle to the middle, measuring that distance. So from here to the middle, and I didn't do this question for homework. I got, let's look, 1, 2, 3. Caitlin, did you get 2.4 or 2.3
For which one?
for F? What'd you get? 2.4 or 2.3? 2.3?
I got 8.3. I think that's so.
Oh,
I got 2.4.
I got
2.3.
2.4.
Emily is off. So here we go. But there's a couple of questions I thought were interesting later on over here. What would be the distance the ant would travel if it crawled on the line from start to point A to point B, then to C, then back to the starting point. So it went A to B to C, and then backwards to the starting point.
See, I didn't know what you meant, so I like did both ways. I did it that way, and if it just went in like a circle, and then I
So-
read the next question.
Okay, here's the other thing that I like this homework, because for some of us who didn't understand exactly, you may have thought that they meant go all the way around and then come this way. Some of us may have thought that. What this homework does though is that this homework actually gives you a path or a line. And since they gave you the path or the line that the ant took, that's the directions that you're using. This was an invisible line right here that you drew in yourself, if that makes sense. This had nothing to do with his path, okay? His path was from here to here to here. There could have been a house and a tree and all this other stuff for all I know that's in the way over here. But this path is actually not here. That's a make-believe path that I drew in. That's the reason why he went all the way that way, and then he came back all the way around. And so if I got from A to B to C, which was 8.2, right? And I just multiplied it by 2, you got something like 16.4. What would the ant's displacement for the same scenario be? 0 centimeters. Does not mean that he didn't move. It just means that he went back to the beginning. Draw a line in the diagram that would represent the negative displacement. Because overall, he was here, he went here, here, here. Then he ended up going backwards here, here, here. If you had to draw a negative displacement or negative line, then hopefully you drew something along the line of this at an angle would have worked. Or if you drew a line straight down, that would work as well. Okay? This is at an angle. That's perfectly good. That's next unit. Give it to me.
I have a question on F.
Okay.
Would you not measure displacement? Okay. When we were doing the example with the lizard on the tree,
Okay, I'm
right?
listening.
We were thinking of it as just one line, and if it doubles back over that line, then your distance would be from 1 to 2 versus. Do you understand? I guess I don't know what I'm saying. Would you not measure from, if you were to draw a straight line from the end point down
Okay.
to, not straight line down?
Oh, this line.
Yes, straight line down. Then measure from your start point to where that line comes. Would that not be your displacement?
We're going to get to that next unit, because if you see what you just said right there, this forms a right angle. And then on that, we find here's my hypotenuse, my adjacent, and my tangent line.
Oh, this is not
And
math
so
class.
here is going to be right here my theta. And then we will see whether or not using SOHCAHTOA, if we're going to use sine, cosine, or tangent. So yes, next unit. But at this moment, no. Everything's in a straight line. We're not having any angles involved.
This is physics, not math class, Nicholson. I have calculus after this class.
Well, good, because
This is
once we do
physics.
our calculus here, you're going to be like, what? They correlate. Yes. Physics is a real math. Math is really used in real life. It's good. So here we go. Number 2.
Wait,
Question
wait, wait.
2 says, yes, can I go?
No.
Okay.
Why is 8 like that? Is it because something could be in the way so you can make a line?
Correct.
I like zoned out.
Yes.
For a second, I'm sorry.
Yes. The answer is yes. Number 2, explain why the distance will always be greater or equal to the displacement of the object. That's a good question. Wyatt, what did you say there?
Oh dear. Okay. Distance and displacement are very similar. However, distance measures the total length something moves, where displacement measures how far away something is from the start point.
I agree with that 100%. Now, one more time.
I mean, the very
Distance and
simple,
displacement could equal each other, but they do not have to equal each other. And we can get a distance, of whatever, a positive value. And if we have a distance, is there any way to have a distance of a negative value? Why not? Okay, whoa. Could we have a displacement that's a negative value?
Yes.
Yes, why?
Well, you made one up there.
Okay. Let's stop. Rethink of our unit notes again. Bailey, they're correct. We can have a displacement that's negative, but we cannot have a distance that's negative. Why is that? The negative just determines the direction, not the numerical value.
Is that line that goes
Okay?
straight
So
down?
that's the reason. And so if you get a displacement of a negative value or a negative number, it's not like you owe money or you owe distance. It's just the negative direction. So we can have negative displacement numbers. We can have positive displacement numbers. We can have 0 as a displacement number. Okay? Distance is going to be the total distance added together that the object traveled. No matter if it took a turn or a curve and then came all the way back. We're going to add all of those values together. Next one though, number 3. Explain how an object has moved around, but yet 0 is the number for its displacement. Give it to me.
It, like what we did with the lizard last week, it goes up, down, then it comes back to its original starting point.
I agree. It moves back home to the original starting point, to where it began, any one of those words. Next one, number 5. A turtle is swimming in a straight line towards the shore and traveling at a distance of 7 meters. Oops, distance. After 5 seconds, T, it reaches the shore. What is a turtle's average speed? Speed equals D over T. I'm looking for speed, so I do not need to rearrange this at all. So 7 divided by 5. Bailey, what'd you get in the back? I forgot, we got 2 Baileys in here. 4 meters per second. I agree with her because those units do not cancel each other out. And those are the units they gave me, so I have to use those units. But number 6, I like number 6. Did you catch it? It says here that
I think
Joey,
I caught it.
did you caught it? Did you?
Yeah, I caught
Did
it.
you? Yeah. Did you catch
Catch
it?
it?
Yeah. Okay. So, well, I
Thanks.
meant like you caught it yesterday.
I had
or the
to
day
use
before.
stuff from Unit 1
Kind of bugged me.
on my first homework.
So the Ski-Doo moves 700 meters north. Okay, he stops for lunch for 1 hour and then drives 5 kilometers east.
I had to write
Oh, so what was the distance covered? At this moment, he moved north and then he moved east. This was 700 meters and this was 5 kilometers. And Malia, what did you end up doing? Did you end up converting everything to kilometers or did you end up converting everything to meters? Because it was not specific. You could have went either way.
I did meters.
She did meters, so let's go ahead and do that. King Henry drinks utterly delicious chocolate milk. We're gonna go to meters from kilo. 1, 2, 3. 5 becomes 1, 2, 3. Add those zeros. This now becomes 5,000 meters. So 5,700 meters is the total distance that he traveled.
Don't you
You
have
have
to
to put
divide
the
the direction, northeast?
I put northeast because I didn't know.
Well, I like that. Okay. Old Bailey. You're my new Bailey. You're obviously my old Bailey. Old Bailey. Do you have to put the direction?
No,
Why not?
because it's asking distance.
And distance is a
Uh,
what's that word? Scalar quantity. And because of that, we do not add a direction to go with it.
If we put the direction on the test,
That's
then that'd be
wrong.
okay.
It's wrong. It's not a vector. It's a scalar.
Okay, let's say I put,
You're trying to justify your wrongness?
yes, let me do that. If
No.
I put 5,700 meters, right, that's correct. I just accidentally put some random-
Accidentally. I actually marked A and B.
Yeah,
My fault.
I accidentally,
Here we go.
you know, put
All right,
letters
Emily,
after
we gotta
that.
keep going. The answer is no.
Man, right? Am I the only one?
Let's keep going.
No, we got it wrong. See, it's not just me.
Probably not.
I'm not on my wrongness on my own.
That's okay.
On my homework, you just see me scribble out like all the
Thank you,
different like
so helpful.
things. I was like, wait, that's not it.
But it makes you think though.
Yeah, it really did because I was really confused at first, and I had to write it out. I was like, that's not right at all. And so you just see like a bunch of scribbles on my paper.
I know, that's why somebody last year said she will not do my, any homework unless she has pencil. Because there is so much scribbles.
Okay,
Okay.
we didn't finish example 2 on the previous page.
Okay.
Or at least I didn't. No,
That's
you
okay.
didn't finish it. Okay.
All right, so here's example 2 on the previous page. Marco's at the DHS track team. He ran 440 meters, which is the distance, in 1 minute and 20 seconds. First step is that you need to convert it, and they told you meters per second. So you have to convert to seconds. That's going to be 60 seconds plus 20 seconds equals a total of 80 seconds. That has to be step 1. Now we're looking for how fast he's moving. All right, it's a speed equation. Why? Because there's no direction. Okay? I can't tell whether it's a speed or whether it's a velocity just because of the SI units. Okay? So in this case, D over T. D is 440 meters. T is going to be 80 seconds. Those units do not cancel each other out. 440 divided by 80 comes out to 5.5 meters per second. Leave it alone. Don't add a direction because it's a scalar quantity. It's a scalar quantity. Turn the page to example 3. Let me get my highlighter out. You're on your own for example 3.
Oh, you're using a yellow.
Distance versus time graphs. These are also called DT graphs, which are speed graphs. One more time. Distance versus time graphs, which are called, and I'll go ahead and put that in parentheses, or I'll put a little line right here, arrow, DT. So when you hear me say DT, that's a distance versus time graph, which is about the speed of the object. That's what it is. So it's just telling me how fast my object is going. First part here. In a DT graph, T is going to be on the x-axis as well as the distance is always going to be on the y-axis. So look at it this way. It's a DT graph, a distance and time. So when you talk about graphs, you always talk about them in the y/x, if that makes sense. The y/x, distance versus time. Okay? When looking at DT graphs, distance versus time, you can have different types of slopes. So here's a line right here, but yet if I look at this slope, we can have different slopes. Right? I mean, we can have less steep slopes, more steeper slopes. And my graphs can be direct relationship graphs or they can be inverse relationship graphs. One more time. They can be direct relationship graphs or they can be inverse relationship graphs. Okay? It says here that both graphs show the same two variables, but the line to the right is much steeper than the one that's over to the left. This difference tells you the objects were moving with different speeds. So the steepness tells me how fast it's moving. It's steeper, it's going faster. It's less steep, then it's going slower. A line's steepness is called its slope. Remember that rise over run? Same thing is going to apply here. And a DT graph, that slope is going to be the distance over the time, which correlates with the speed of that object. DT graph. Few examples. It says here, determine the average speed of the car in the following graph. Okay? So when I'm looking at this graph over here, they're asking me what's the total distance. My object traveled, total distance of 300, here's my units, miles. MIL. Total time. The time that it took was 6, here's my units, hours. HR. Find the average speed. Well, first I'm gonna go ahead and say speed is d over t, and I'm actually looking for speed so I don't have to rearrange it. So it's gonna come out to 300 miles over 6 hours. My units cannot cancel each other out. I'm gonna end up with 300 divided by 6, 50 miles per hour. Now, let me pause real quick. This is a DT graph. What does a DT graph tell me? It tells me speed. Speed is a scalar quantity, so we do not add a direction. Okay? One more time. Everything in physics is broken into either a scalar or a vector. It's important to know everything in physics, which group it goes into, because it tells you whether or not it's going to have direction with it or not. Turn the page. So it says, let's go ahead and continue looking at some of these DT graphs over here. So they give us a DT graph that actually has, could we say this word? No slope? Right, there's no slope there. It's just a straight flat line. Just a straight line. Then they give me a direct relationship graph, okay? Then they give me an inverse relationship graph. An inverse means opposite. A direct relationship means when one goes up, the other goes up. And an inverse means that they're opposite. One goes up, the other goes down. When one goes down, the other goes up. So they would like us to go ahead and calculate the speed of all of them, okay? So let's do that. Before I go any further, let's look at this first one. Because they asked me for the total distance that my object traveled. How far did it move?
20 miles.
Marshall, how much?
Oh,
Whoa!
it didn't move at all.
Whoa!
Stayed constant in 20 miles.
How do you, okay. Okay, he said it didn't move anywhere.
It didn't. It started someplace and it
Thank
didn't
you.
move.
It started at the 20 and it never moved. I agree with him 100%. It started at the 20 and it never moved. Just because there's a 0 over there doesn't mean that everything starts from home, from the start or from 0. I agree. 100%. But the total amount of time that this object stayed and started at the 20,
7 hours.
give it to me.
7-ish hours.
I like that, 7 hours. That's what I got. So my equation for speed is d over t. Let's go ahead and do the work. Distance is 0, time is 7 hours, and that is miles, 7 hours. My answer is 0 miles per hour. Is that possible? Absolutely, it's possible to have a 0 as an answer in physics. And here's one thing. When you see a straight line like that with no slope on the DT graph, it means 0. It means 0. It means wherever it's at is where it's at, and it's not even moving. Let's look at this direct relationship graph over here, though. They asked me, what is the total distance? So my total distance over here, let's see. Wyatt, what is it? 115? Oh, did I?
110.
110? I'm sorry, I went
no.
down. I can get my ruler. Andy?
Just round it to
100.
100, please.
100.
100?
Yeah. I thought that 100 was a 110.
Oh, my bad.
But the total distance isn't 100
Why not?
because you start at the 20.
Oh, that's true.
Ooh.
She got
That's
me.
80.
Got you. So it's 80 miles. Agreed. But everything starts at the 0 regarding time, all right? And time only moves forward. And I can see that time went to this right here.
8 hours.
What is it again?
8.
8 hours.
I think it's a little farther than that.
Speed equals d over t. You called it 8, so we're going to call it 8. 80 divided by 8
Equals 10. I'm gonna say 100. That's not right.
miles per hour.
This is not my day.
That's okay. It's a weird Wednesday/Monday issue.
Why should not have been driving that?
All right, sorry. So let's keep going. We've got another one over here. This is a inverse relationship. The total distance. My object actually started at the 100.
Negative.
Whoa, what?
No. So distance. So you're traveling down.
Whoa, how do you know it's down? Just because the line is down?
No.
Distance
Did
is
it?
a
Because
negative.
did it start
Whoa, whoa, whoa,
7
whoa, whoa,
hours
whoa, whoa,
out?
whoa.
or something?
Let's go back to Old Bailey. Old Bailey. What did you say about speed?
Speed? There's
Yeah.
anything about speed. I talked about distance.
Well, distance is part of speed. I know.
It's not based on the direction.
It's not based on a direction because it's a scalar quantity. So I don't want to hear the word down. But that makes sense. Okay? It started off at the 100 and it moved whatever. But it ended at the 20, so it's 80 again, not negative 80. Okay? I just want to make sure that we're all on the same page. I'm going to go ahead, if that's okay with you, I'm going to call it 8 hours. 80 divided by 8 equals 10 miles per hour. Okay, I actually do not know if it was going left or down or south, but I will give you a little bit more regarding direction in just a moment.
So,
Okay.
quick question.
Make it quick.
There's never negative distance, right? Isn't that what you said or something?
Not for distance, but displacement, yes.
Thank you. So this
But
couldn't
it's-
have been negative anyway.
Correct, because it's a speed, which is a scalar quantity. The next part though, let's just take a quick, let's look at this DT graph. And I want to tell you a little bit more because I understand when you saw that graph over here, it made you feel like it's going down or south, okay? But in a DT graph, which is a scalar quantity, I don't know exactly if it's going down or south or to the left. But what I do know is that when I have a line that's going an upward slope, then it is moving. Did you see that? Okay, good. Away from the origin, or away from home, away from the starting position. When you see a DT line with a flat line with no slope, it means that my object is at rest. No motion is moving or going on. There's another line. It is an upward direct relationship line. Again, it's moving away. Away from the origin. I have no clue if it's going north or if it's going to the right or if it's going up. I just know that it's moving away from the origin. Then when I have a downward inverse relationship line, then that tells me that it's moving back home. Back to the origin. Back to the beginning. Back to the start.
What's the difference between moving away and away?
I'm sorry.
Oh, same thing.
Yeah.